Here is everything I learned today as a software engineer trying to learn machine learning. Day 3. If you haven't watched previous episodes, I highly recommend doing so before watching this one. Finishing yesterday's episode, we had our hypothesis and we had a way for measuring how well it fits into the data. Our goal is to minimize the cost function, and that way we can know that our hypothesis makes good guesses. That's where gradient descent comes in. Gradient descent is an optimization algorithm that helps us improve our hypothesis by minimizing the cost function. A simple way to see the value of the cost function for each pair of θ0 and θ1 would be putting θ0 on the x-axis, θ1 on the y-axis, and the cost function on the vertical z-axis. Looking at this graph, our goal is to get to the very bottom of the graph. Starting from randomly chosen θ0 and θ1, we check the slope of the landscape at our current location and we use that to walk downhill from our starting point until we reach the bottom. Our step size is affected by two things: the slope of the landscape. The steeper the landscape is, the bigger our step, and the learning rate, alpha. Too big and we might overshoot the minimum, too small and it will take us forever to reach the minimum. Mathematically, alpha is the parameter in which we multiply the partial derivative of the cost function for updating both θ0 and θ1 simultaneously. Something you might have noticed is that changing the starting point can change the final θ0 and θ1 we reach at the end of the algorithm. For example, starting from this position, we might end up at a point which is obviously not the very bottom of the pits in our graph. The good news is that in our case, with linear regression, there is only one lowest point, a global minimum on this landscape, which means that gradient descent will get you to the lowest point. It doesn't matter your starting point. This is it for day 3. I hope you liked it and make sure to subscribe to the channel to follow my journey.